Hi. So that is a question. Uh, so I'll post the uh, question details or it comes. Okay. So here it is asked to find about f to the power n some details of it. Okay. So let's read the question. So it will be a bounded open set of C with containing zero. So you might be the disk or something. I mean, it should contain zero. And f is a function from u to u. So the codomain is also u. Okay, is holomorphic with f of 0 is 0. Fine. And f to the power n denote the composition like that. Okay. So f square will be like f composition f. Okay. So f prime denotes the derivative. So which of the following are true? First option is f to the power n. So that is a function, right? F to the power n is itself a function. So if we do derivative of f to the n and find the derivative at 0, that is equal to a prime 0 to the power n. That is a complex number. Here the n is power, but here the n is composition. Okay, so that is the difference. So that is the first option. Second option is f to the power n u is a subset of u. It means like f of u subset of u, f of u should be subset of u also. Like that they asked. Okay, if it is true or not. And the third one is if prime 0 to the power n is bounded. That sequence, as a sequence, that is a complex number and there is a power. That sequence is bounded. So there is something to be observed. So if we prove that, we can use here, we can use that here, right? We can, I mean, if it is true, then we can say if fn prime 0 is bounded, then that is bounded, right? So I mean some observations. I'm just saying. Okay. Now let's see what can we do. So first of all, what is I mean I wrote what is f composition like that. So we have to find about fn prime, right? Fn prime of z. So let's see how this works actually. How these things is I mean this thing happen. Okay. So first of all, for two function, let's say f composition g, how the derivative is like. So ddz of f composition gz, we know by chain rule that becomes a prime gz product g prime z. Okay, and for three function f composition g composition h, we know that ddz of f composition g composition h at z is equal to f prime of g of h of z dot g prime of h of z dot h prime of z, right? So for n function, it will be like that. So for I mean n composition or I mean here all functions are same and the composition is n times. Okay, so ddz of fnz will be like f prime of, see what we get here. It is like g of h of z, right? So here it will be f only, but the composition will be n minus 1 times. Then dot, that is simple multiplication. Again f prime because we have to do differentiate that thing, right, with respect to z. So that will be like f prime. Then here it is just hz, right? So it will be f to the power n minus 2z and so on. So then it will be like f prime of to the power n minus 3 of z dot like that. Then at the end it will be like f prime of z. So here we have something, this thing, okay, that we will use. See what do we have. Okay, so we have to find a at 0, right? So fn prime of 0, that will be f prime of If n minus 1 0, then f prime of f n minus 2 0, like that. So here we will prove that dates are 0, like f to the power n 0 is 0. That we will prove. How? That is easy actually. So f of 0 is 0, then f square 0 is what? F of 0, then and that is 0. So f of 0 is 0. So like that it will be 0. So hence this thing are 0, right? This is 0. This is 0. So what? So a prime of 0 0, right? So it will be like a prime 0 power n. So 1 is done, right? And for 2, f of fn of u subset of u, they asked to prove that. So f of u is a subset of u. So obviously f square u is equal to f of u, and that is subset of u, right? So if I mean g of some v is a subset of g of u, it happens when v is subset of u, right? If v is subset of u, then this happen. So for any g arbitrary function. So here f of u is a subset of u. So yeah, that is you can understand easily. So that's like that it will be done. And for the third one, that is bounded or not. So I take the function f of z is 2z. Okay. Here f square z is. So we will prove that they ask to prove if a prime 0 to the power n, that sequence is bounded or not, right? So we'll prove that, I mean, we will see about that function, that not that sequence actually, because these are complex ones, right? So because they are same, we prove that. So here f square z is 4z, and f to the power n z is 2 to the power n z. So what is f to the power n prime 0? That is just 2 to the power n, right? But that is an unbounded sequence, right? Right? So 1, 2 are true and 3 is false. Fine.